All right, so an introductory concept for this module is the unit step and unit impulse functions. They're just two functions in the time domain that we need to talk about in order to make sense of some of the stuff that's going to happen in this module. And so you've already seen and used the unit step function. We just haven't called it that. In 220 specifically, those of you who took 220 with me, you remember that we would have something like a pulse source that was going to pulse from, let's say, 0 up to 5 volts at some time delay TD, and we were going to send that into an RC circuit or something, and the behavior of that voltage, right, it would look something like this. It would basically sit at 0, and then it would pulse up and stay at this value, V, let's just call it 5 volts in this case, starting at 0. And at time TD, it pulses up to 5 and it stays there, okay? And so we would represent that in the time domain. Let's just call this Vn of t. We would have represented that Vn of t as a piecewise expression that's basically 0 for t less than TD, and then it's 5 volts, or 5. Let's just put the V in parentheses so we know it's units of volts, but it's really just 5 for t greater than or equal to TD, okay? And so that's how we would express this. Well, you'll notice that this is very similar to this unit step function. By definition, the unit step function is just a function that's basically 0 up until some time t, which in this case, that t is 0, and then for all time after that, it's got a value of 1. That's the unit step function. Of course, we can shift this along the x-axis here, and we could say that it starts pulsing up at some time t, and then that would be just a time-shifted version of the unit step function, right? And instead of t less than 0, it would say t less than this value of t, right? This is just the unit step function, and then we can scale this unit step function. So if we wanted it to be 5, 5 after some value of t, we could just multiply it by 5, and then it's still going to be 0 in this region, and then it'll just be 5 in this region. Okay, so this is the unit step function. And so if we wanted to write this in terms of the unit step function, we would basically just write 5 multiplied by u of t minus td, right? That's all it is. It's the unit step function, which is this, except we're shifting it by td in time, and then we're also scaling it by 5 in the y direction. And so that's it. This is basically just a way to represent our input pulse as a time domain expression that's a little bit more concise and easier to work with than something piecewise like this Vn of t that I've written here, specifically because there's a Laplace transform for this function that's going to make our lives a lot easier in this module, okay? So hopefully that makes sense for the unit step function. We're going to talk more about it as we move through this module, but I just wanted to introduce the concept here. Let me just say it one last time. The unit step function is basically a function, u of t, right, that starts at 0 for all time less than 0, and then pulses up to 1 for all time greater than 0. And then, of course, we can scale this function and shift this function in time to get different unit step functions, or different step functions, I should say, that aren't necessarily the unit step function. Unity or unit means 1, right? It's called the unit step function because it steps from 0 to 1. But if we scale it and then shift it, it's no longer the unit step function, but it's still a step function, and it's just a scaled, shifted version of the unit step function, okay? And so this is an important principle in these circuits, is that we can basically represent a pulse source in this fashion. We could also represent a DC source with a switch closing in this fashion, right? If I have this circuit right here, initially this voltage might be 0, and then when I close the switch, it would pulse up, And so I could also represent the voltage between these two terminals using a unit step function in the time domain. Okay, and so this is important because we need to make sure that we know what all of our functions and all of our components are in the time domain before we can use the transformation over to the Laplace domain, which is something we haven't talked about yet. But keep this in your back pocket. We're going to talk about this a little bit more. I'll go ahead and wrap up this video, and in the next video I'll talk about the unit impulse function, which is another type of special time domain function that we need to talk about.